Our next speaker is Martin Visser. He is an hydrologist at Deltares, where he focuses on integrated water resources management, building Ribasim and Julia on the top of SciML and Julia JUMP solvers. A key application of this module is for the national water model of the Netherlands. As an early adopter of Julia programming language, he has been active in the open source community, helping to set up and maintain JuliaGeo and its packages, which aim to make it easier to work with geospatial data in Julia. I welcome Martin Visser.
Thank you. So the time live demo will be a bit more live than I had in mind. But let's start with some slides that I did have ready already. And so the title of the talk is Julia on Trial. Specifically on trial in our organization that Martin and I both work at Deltares. And so this is not just about the technology, but about institutional issues related to tech adoption. So yeah, this is Deltares, by the way. We're about 800 people in Delft, in the Netherlands. We do a lot of simulation, think about flood forecasting models, but I specifically work more on water resources models. But we also have a lot of physical facilities, for instance, like the largest wave generator in the world. And there was actually another nice talk a few years ago by ASML on adopting Julia within an organization, and ASML is of course still much bigger than Deltares. But I really like this slide, so I just took a screenshot from their YouTube video, and because I recognize this very much, and Julia aimed to solve this two-language problem, and also at our institute, we have the scientists that come more from the domain, that are more used to languages like Python, R, MATLAB, and that just want to get stuff done. And then there's the more software developer part of the organization that for instance, is more responsible for developing and maintaining the simulation kernels that we create. And well, coming from the left side but working more on the right side currently, I see the problem, and I'd like to increase the area under this midsection of the curve. But I started using it at Deltares, I think in 2013, just on the left side, because it's quite easy to start using it in projects for throwaway scripts, so to say, notebooks, and nobody is going to make an issue out of that. But since 2020, we started moving actually some of our simulation kernels to Julia, and so that's much more on the right side of this graph. And by now we have two of these kernels written in Julia. One is actually moving over from Python, that had part of its core in C++ for speed, but the one I'm mainly working on now, the water resources model, that's used also as the Dutch National Hydrological Model. That's basically a renewal. It's not a port, but it's replacing a Fortran code that dates back to the 80s. And so yeah, a lot of these older generation simulation software is written in Fortran, and of course Fortran is showing its age in several respects. Um, um, but yeah, and this is these products, in a way, they still look a little bit like the old Fortran kernels in terms of the way that the user uses them, and because uh, they are command line application, and we offer a lot of buttons, the way that Milan phrased it yesterday, and like I think it would be nice to make it even more interactive, to make that bridge from the scientists to contribute to the kernels even easier. But I think that was, for now, it was a step too far. Although, yeah, even now, being with the core being in Julia, it's easy to see already more of the scientists there. They're less afraid to start diving in and contributing here and there. But basically, we package it all up, so most users, they don't really need to know about Julia if they don't want to. But and since we started moving some of this code, we've also become a little bit more professional in the software engineering term, employing software architects, and to really think about the technology choices that we make. And one thing, we have this tech radar where we it's just an open website, but for a lot of technologies that we use, we kind of put them into one of four categories: adopt, trial, assess, or hold. And so Python, for instance, it's being used a lot. It's in adopt. And MATLAB, it's still being used, because in civil engineering, it's just a lot of university students, they are very familiar with it, but we're trying to wean off it, so to say. So Julia is in trial right now, and that means we are using it, as you can see, but there's still not a stamp of approval, like, hey, we want to, whenever we build a new simulation software, for instance, that would be the logical choice. For that to happen, like what the architects, our colleagues, also said we're missing, one of them being the security tooling. Part of these are requirements by our customers from the government, that we need to have security scanning in place, and to be able to show like a software bill of materials, all these kind of things. And so this is a requirement that is it's pretty Boolean, if you wish. Like it's either it's met or it's not, and if it's not met, then it's really hard to like adopt it. So that scared us a little bit initially, but we can of course also help ourselves. So we started helping a little bit in the ecosystem, and there is actually already quite an effort ongoing, and there's a security working group launched this year. So more and more tooling is getting in place for that. So that's going quite well. And the other one is more developer tooling. As for the other languages, it's also, and for instance, for Python some years ago, it was a bit more messy. so many package managers and dependencies not working well. But for instance, with UV and Pixie appearing in recent years, that has gotten a lot better as well. So that's actually something that I'm thinking about currently a little bit, to see can we not have something a bit more like UV. We have a great package manager, but it doesn't have a command line interface currently. And using Julia, if you send somebody a Julia project with a manifest, it should be really easy for them to run your script. But right now it's not really. You need to install the right Julia version. You need to activate the right environment. You need to instantiate it, and then you can run it. So those are already quite a few steps that might scare off some new users. So I started working a little bit on this JL tool. I can just show it. So it's currently a package app, but consider it more as like a early prototype to think about what could a good API for this be. So you can install it if you're using Julia 1.12 and just add this. And if you have this path in your path, then you'll have JL. So if you just type JL, it's probably, and you can see the commands. So a lot of this, I should say, the basis of this is taken from Christopher Coulson, that made a pull request to add a package app to package itself. So all these commands are from there, but I added some things on top, especially to initialize and to run Julia scripts. And I'm thinking to add even more. What can we do? So we can init create, let's see, we are now here, and let's create a new project. So what this does is it creates an empty project, and let's just actually go there. And you can add a package. JL add example. And so what I can also show this right here, and because if you have a script in a project, you can just do JL run hello, and so even if you don't have the project instantiated, it will do that automatically for it. It will find, based on the location of the script, the nearest encompassing project, and activate, instantiate that, and then run it. So if you do that for the first time, it will be slower, and then it will be faster after that. So this is a package app. And it would be nice if people think this is a good idea. Then probably everybody should have this in their path. So because there's some background here, and Miles Cranmer did a very similar thing, but adding it to Julia up. But this was still the scope being just a command line interface for package. So it's called Julia package. So what I'm proposing, and I could easily, we could easily port this to Julia Up as well, to have it called JL and expand the scope a little bit to easily, to offer a nice CLI experience, also to run scripts, and also, and then at the same time, and we can directly change perhaps some defaults that we cannot easily change in Julia itself, the executable. As some of these features, they are already available in Julia Up, to, for instance, and you want to automatically select the right Julia version based on your manifest, and that's now possible in the unreleased version of Julia Up, but also even going so far as to automatically install the right Julia version. I'm curious to hear your thoughts on it, and if this is something worth pursuing. Thank you.
Thank you. Yeah, so just one small comment. This was sort of discussed also last year at Spatial Data Science Across Languages, that you could use Julia as a sort of replacement for C and C++ and Python.
Right.
While we were discussing that, one point that came up was that a lot of the reason you use Julia is so that you can very quickly change APIs, right? And it's sort of a lot easier than C++, because with the C++ Python interop, you have to have a lot of this scaffolding because you're effectively passing in C objects. With Julia C, you lose a lot of that flexibility, right? Because you can no longer, like, you have to massage everything into something that is compatible with C, right? And so that is almost kind of a point against Julia as C or C, as a direct C or C++ replacement. But like, there are some contexts in which it still makes sense for like numerical kernels or things like that. There are some contexts in which I think it's probably better to just ship Julia and have that compiler available.
Yeah.
But just a small comment. I noticed that in your last slide.
Thanks. Yeah, and we are currently using package compiler, but I think having trimmed Ribosim, for instance, it's still a bit of a ways off. But would be nice if we could get there, given what it is currently. But I agree in many other use cases, if you want more interactive modeling as well, that you probably gonna want a compiler.
Nice presentation. I just meant to say that to me this seems very useful. It's something I would use, especially when I want to communicate tools to other people and have them try them out. Right?
Yeah.
And in that context, I was thinking, having a sort of a support for the Pluto notebooks that I like so much, that have this information about the package, TOML and in there, would help me specifically, and I think would be nice.
Yeah, that's so, and like very little of this is actually my work, and a lot of it is features that are already available. In some cases unreleased, in some cases disabled still by default. So I think just trying that out together and enabling all these features, can really help. If for the Pluto, I'm aware that they include the manifest, and there's I think it's still a work in progress pull request for PKG as well to add that to Julia itself. And so once that exists, then you don't need to ship a folder, but you need to ship a single file, and that would be enough. So I agree that would be nice. But that would come for free basically once that lands.
And I guess I assume that the parallelism sort of also comes from if we put in the script, right? Or do you have an option, or do you think of an option to be able to specify the computational infrastructure, say, or the number of processors and things like that?
Yes. So I was looking also across like JuliaUp and some other discussions, because and what I like about UV is that it puts everything in the PyProject.toml, and so being able to organize more metadata about your project, like the number of processors, optionally in the project.toml, I think would be very nice, because it will make it more reproducible. If your code only works well with 4 CPUs for some reason, then you have a place to put that, and everybody's going to have that. Yeah.
This is really a great approach, and I was not aware about all this discussion there, and I'm wondering if it's possible to add an entry point to PKG. So in the same way that when you run IC, the formatter, you just type Julia -m run IC, and it then calls the add main entry point, and then formats the code. Yeah, exactly. Oh, it would be really nice. Well, this also works with plain Julia, right? So you can just type Julia -m run IC.
Yeah.
And I'm just wondering why we don't have a package manager. Well, PKG does not have an entry point like this, where I could just type Julia -PKG status, for example.
Yes, so I think that's I've seen similar suggestions in the discussions for around this topic, but my feeling is that Julia, the verb, it's already overloaded. It's like Julia itself. It's like JuliaUp that adds the version selector thing, and adding more flags like that with a whole subcommand, it might also be breaking. Plus it would be longer to write than JL. But related to these, because I didn't really discuss package apps in general, and package apps are currently global, and it's only global, and that's, I think, a bit dangerous, because either your Julia version can disappear and it won't work anymore, or it could be, for instance, JetLS is using like now test runner JetLS or in your global environment, but you might have a different project that you want a different version of those tools. So it might be nice if this also adds an easier way than this to just make available local versions of apps.
Something to look at also is the -m flag for Julia is a bit similar to what you have in Python.
Yeah.
When you just use the JSON, for example, module to just print JSON.
Yeah.
So that would be quite interesting if every package could have with a -m, with the module option, has an easy way to also provide a command line interface. So maybe, So from this perspective, I was wondering if the package manager could do the same.
So I'm using this flag here, and the package apps kind of translate this to a command line interface. But here I would kind of want to translate back again, so I'd have to figure that out. Thank you. Okay. Thank you.